Well, hello again. It's Saturday, and instead of doing a customer's job, we will do my job. I bought this on eBay for too much money during this week. You don't see many around. We've covered this before years ago. I probably did it in 2014, so we'll do another one. So from 1981, I think we'll be making one out of two. It's the Colt 355. So it's basically like I would think it's going to be the Maxcom 21E in a metal case. So which one? Well, that's the better front, isn't it? And that's the better case. So oh my goodness, what's happened there? These were definitely, you know, spares of repair. So that's been chop block. We can sort that out later. I will open this one up just to see whether there's any innards. I better put the soldering iron on because this is going to be a speaker remove job. You know what? I think this is the better set, and I think what we'll do is when we're done, we'll swap the fronts over. I will just look in my stash of fronts that I bought off eBay some years ago, which was disappointing because half of the fronts were not for UK radios. So it's either put them on eBay for American customers only or bin them. So at least it's got the power lead, the power stub. We've got the mouldings for these anyway. We'll sort that out. So the yellow wire is positive and the yellow wire is negative. So, you know what? We'll stop the confusion, rip those off, throw them in the vertical filing cabinet, unsolder the speaker, that's a good candidate to do our demonstration of respraying CB cabinets. Yeah. Hang on a minute, that doesn't fit that set. No, look. That's the correct lid, isn't it? It's not one off. You don't think it's one of those Falcon FCB 1281s, I wonder. Anyway, that we'll do that just as a thing because I'm going to do a demonstration on spraying fronts. It's chucking with rain outside, so I think we'll start that today. It's going to be a several-day job. I don't think we need to touch that. That's just as it should be for its age. So we'll connect it up to, we were on 13.2 volts yesterday, so we'll be on 13.8 today. So I don't think I've seen one of these radios since I demonstrated the last one all those years ago. Yeah, we'll soon have that power lead improved anyway. Oh, it's on 19 and it does at least light up. Like most of the Maxon radios, or all the Maxon CB radios we seem to see, or Maxcom as they were branded. They may not have been the best performers, but they were competent, and most of them still work 38 years later. So we'll put the signal generator on. So we've got some not very good sounding receive. We've got S9 on with a with a 100 microvolt signal from the signal generator, which is actually reading about right. There's no mic plugged in. Are they supposed to make any noise when there's a mic? Most radios don't. That could do with some service on the volume control. There we go. That's sorted that first problem. So it does receive. Now, I might have to make a mic up from this. I can see we've got a 5-pin DIN mic on the bench, but that could be for a DNT. So we'll just plug it in and see what happens. Well, it certainly isn't for that. Yes, it's one on the bench that didn't get labelled. Okay, I'll make up a mic. Okay, well, I've ended up rewiring the mic which was on the bench, and hopefully I've done it correctly, because I hadn't got any in stock. We used to have a computerised stock control system, and the hard drive went down on the 486 computer, and, you know, I don't have to tell you the rest. So, let's see what happens now. Got receive, we've got transmit. So if I put picture in picture on, it's doing just under 3 watts. We've got coil. Oh my goodness. 1, 2. I'm going to have to go up a scale on the deviation. 1, 2. It's doing 4.5 kilohertz deviation. So that's good fun for talking on several channels at once. And just for the record, we'll just see what the cyanide reading is for receive. We'll just do 12. It's always between scales. It's actually 2.1. Oh, I'm doing 20. Whoa, Wally. It's exactly 1 microvolt for 12 decibel cyanide. Without cross-referencing it with my previous job, we'll have to just find our way through what's what on transmit. So, see, we'll start off on the 3 watt scale. That's probably going to be we've got a situation where the cores are all broken. Yeah, that was predictable, wasn't it? Well, this is going to be fun. So that one, I think this is probably the 54 meg trap. That one's not actually tight. So at the moment we've got just coming up to 3 watts, and every core for transmit is damaged. So I'm just going to make sure the receive ones aren't. Now every single core in it is broken. So every single inductor is going to have to come out and be turned round and all that. So we've got 1, 2, 3, 4, 5, 6 transformers to remove. So I've got my work cut out today, and I've got other things to do. So I'll go through the first one with you all. I've unsoldered most of these, I think. You can't necessarily see. Let's just zoom in a bit. It's camera 1. So we've hopefully unsoldered most of these. We use a solder sucker, which is an RS Components one, because we've found they actually work if you actually put your finger on the end and press. It's got that kind of suction. Do that again. So they're good. So I've taken this one out. And what I'm hoping is, I don't know whether you can see how mangled that is. What I'm hoping is to be able to, because it's perfect underneath, I'm hoping to be able to, I can use our metal tool. I think it's stuck solid. I'm going to carefully apply some heat to it. What we don't want to do is melt the plastic former. You can't be in a hurry. Not liking that last bit. So there we have it out. So I'm just going to poke that tool through there to make sure there's nothing stuck in there. So we've got a core that's only damaged at one end. So in this case we can just turn that round, and I'll put it in from the top if the core isn't mangled. The coil core, the former I should say. I'm putting that in by hand. I'll just put it to the top. So we've now got that in perfect working order once again. So that's we've got 1, 2, 3, 4, 5 to go. So they've messed up the transmitter, they've messed up the receiver. I mean, it's receiving very well, but is very well as good as it can do. You know, there's a difference between acceptable and perfect. And at the factory, as you know, all they can do is quickly tune them to the minimum, and the radio's sold. Well, we can do better than that. There we go. Right, I'll get on with the next ones and see you in a bit. Okay, so we've done that. And that's one which is, two of them broke in trying to drill them out, so they had to be replaced. They have a number on the side, 34102 on that one. And I had a scrap, what's this? Midland 2001. And so the two which broke, I've been able to pinch from there. Now it's a different layout, but it's going to be similar parts. So what I didn't do was to pinch parts off the other one of these, because you never know. So put this scrap Midland down, zoom out the camera, and now we will have to tune it, because did I take the core out of that one? Okay, we're back with you. I just tuned it up with a monitor receiver because it's very low level, just to get transmit. So, where are we now? Well, we're back to the 3 watts which we started off with. So hopefully, the first one's transmit. The second one's transmit. Oh yeah. Well, that got some smoke out of it. So we're now at 3.3 watts. 3.3 watts. .3 watts, and either that one's another one that's still broken, or it's just stiff. Yeah, it's about 3.3 watts, bearing in mind the radio is now hot. So I'm just going to do some of these again. I don't think anything's been tampered with. There's no stretched coils or anything, so that's probably how this particular one is. Low power, and we've got 110 milliwatts, so there's going to be a preset for that somewhere. I'm not sure where the presets are. We'll just mess about till we find them. It really doesn't matter. We'll soon bring it back. That's the one. So that's now 400 milliwatts, which is exactly where we want it. That camera is zoomed in far too far, and you can't see properly what I'm doing. So 400 milliwatts, and on full power we've got virtually 3.5 watts. So, there will be an RF power meter preset. But I'll tell you what, before we do that, let's just see whether it's on frequency. I mean, that's taken over an hour, and of course I had to have a scrap chassis available to me to do this. Not of the set, but I said with that Midland 2001, which I happen to have got. So, frequency 27.79124, toggling 125. It's spot on frequency. The red trimmer capacitor there next to the reference crystal would be what would bring it on if it wasn't. So we'll just go back to the power meter just for the hell of it, and we need to find out which the RF meter is on the radio. So I would think it's going to be one or the other of these. It's not that one. It's that one. There we are. That's set to 4. Switch on the back, we get 1. That's exactly what you'd expect it to do. So that's set that up, and it's the upper one of those two, which means that will be the receive one. So we've got deviation to do. I say that if it's got a receive one. Deviation. Do you know what? It could be that, because that's at full, but no, it's going to be that. That's at full. So we'll get the little oscillator out, and hopefully, as you can see, it's beyond full scale deflection. There we go. Wallow. 1, 2. That's a bit low now. Funny that. Wallow. Okay. So that's that done. That was deviation next to the red trimmer for frequency. So that's transmit done. We will look at it on the spectrum analyzer. So it's not being messed with other than the broken cores. So what was it when it came in? It was just like 3 watts, so we've kind of gained half a watt out of it, but it needed to be done. It's a lot of work, but it needed to be done. Alright, we'll move over to receive. And we'll start off with S9 on the signal generator, and we'll look at that waveform, and I think that's the detector there, or the discriminator, depends what you want to call it. It was spot on. Now we'll go over to the cyanide meter and see whether we can improve the way the receiver was. Now, behind the scenes, I just by ear put these somewhere near, because obviously I've changed these two. May as well use a ceramic trimmer. I think that's it. No, can't see any more hiding. So now we'll look at the sensitivity. So 12 dB, do you remember it was 1 microvolt? Well, it's now 0.75 microvolts. So, as I say, although it was receiving, I thought we could do better, and we could. So 0.75, I mean, it's not going to blow the world away, is it? But it's fine. 10 dB is 0.55, and if we can get 20 out of it, it is 1.4. So we inadvertently did 20 and it was 2 point something. So yes, it's improved the receiver, and that was the object of the exercise, to get the radio as good as it can be. So S9 on the S meter. Now, that was correct before, but I've messed with the trimmer since then. It is 4 lights, so let's just make it 3. And then it's got room for plus 30 as I turn the signal up. So that's a nice way to do it. I'll tell you what though, for that other one, to have a front... Oh, to have a front like that, and this to have a worn front like this, you know, it's obviously had quite some use. Squelch. Oh, channel 9 switch. Takes the display out and puts the light on. I suppose I better check it really is channel 9. Hasn't been turned into... Yeah, 68125, that's fine. So, squelch, turn it to full. 100 microvolts on the radio, and it's going to be the preset there. I think that's just a little bit dirty, so we'll use the Servicel Super 10 as we usually do. There we go. Yes, that's coming in as 100 microvolts. Turn the signal generator off, set the squelch threshold. Signal generator on. See when it comes in. Coming in at 0.6 of a microvolt. And it's going off at 0.4 of a microvolt, so it's a useful squelch sensitivity. So there we are, we're done. So I'm going to go over this with isopropyl alcohol and then we'll be back. Okay, so there we are with the radio looking a bit better. So I need to remember where I put the cases for this radio, because we're going to do the spectrum analyzer bit. It would help to put the bottom lid on. So before we leave this, just make sure it's still doing some power. Helps if we turn it on. Yeah, 3.5 watts. There's our oh, so better go put the signal. There we are. So there's our fundamental frequency of 27.79125, and we'll just go up looking for some junk. Okay, we've got one there at 137. I'll put in 54 and see what we've got there, because I didn't see that initially. So we have 54, so let's see if we can measure that. It's a bit high, that's not in spec, it's 41 minus 41 dBm. In actual fact, it needs that coil stretching slightly. Nope, that didn't help. Put that back normal. Well, best I can get is minus 46 dBm, so it's not quite in spec. Anyway, that's how it is. You know, if that was going to be somebody's base station and in a lot of use, and you know, right next to the police station or something, you know, you could put a low pass filter and improve the results. But it is very slight out of spec. I think it should be minus 56 or something. It's a bit high. Anyway, that's how it is. Just see what it's doing. I'll turn that off. Turn picture in picture off, and we'll just see what it's doing on the Zetagi meter. So it's doing 3.5 on the Marconi and 4 on the Zetagi. So we know that's we know that's reading a bit fast. So that's reassuring. And I will just see what the results are if we key up with a higher voltage, like they do with the modern sets, and tell you it's a 4-watt set but only at 15.6 volts. So we'll go back to picture in picture. I will turn up, we'll put that on there, we'll turn the spectrum analyzer off, then we haven't got the fan rumbling. I'll turn up the power supply whilst keying up. Try not to destroy the set. It's doing 4 watts at 16 volts, so I don't suggest you try that. And if we drop down to 12, the radio is then doing, I'll go to the other scale, it'll be easy to read, 2.5 watts. And at 12.8 volts, it's doing 3. So it's not really in the normal range of the 12.8 to 13.8. Your difference is only really about 3 to 3.5 watts. So it's not so bad, that. Okay, we'll put it on the aerial and we'll see if there's any bad buddies out there.